good morning to everybody. I hope this is going to be an informative session for all of you, and that it'll give you a bit of insight as to what shock absorbers do and the value of them in your vehicle. So without further ado, let's carry on and with shock absorbers and the importance. Let's start talking a little bit about suspension systems. And I'm going to run through the following menu list of discussion, being basics of suspension, comfort and safety, front suspensions, main components, rear suspensions, spring design, and strut mountings to finish off with at the end. So let's just talk about the front components of the suspension system for a moment and discuss the six basic functions that they perform. The suspension is made up of a whole number of parts, and I'll show those to you in a moment. Primarily, they maintain the correct vehicle ride height, and that's the height of the vehicle off the road. They reduce the effect of the shock forces. Obviously, that's where shock absorbers come in. Maintain the correct wheel alignment. That's all your suspension connections, your steering and adjustment and alignment, ball joints, tie rod ends, rack ends, and so on. They support the vehicle weight, and we'll talk a little bit about unsprung weight and sprung weight. They keep the tires in contact with the road, and they control the vehicle's direction of travel. So if we look at the basic vehicle suspension, the three main components that need to be in really good working order is the tire, obviously, because that's what keeps you on the road. The springs, and the springs give you the ride height, as I was showing you earlier. If we look at the position of the springs over here, the spring in the front on the McPherson strut, and then the leaf spring in this particular instance at the back on the rear. And then the shock absorber. And the basic function of the shock absorber, interestingly enough, is to keep the tires in contact with the road. And that's that patch of surface at the bottom that needs to stay down in order to give you the road holding that you need. So if we carry on with the next section, if I can get it to change, sorry, a second. Right. There we go. So what are shock absorbers? Shock absorbers are dampers, and a damper is anything that absorbs something else. Springs provide the lift and height to the chassis and body. Now, if you think about a spring, what is, by virtue of its name, as a spring, it bounces, and it will continue bouncing until it loses the energy that has been induced into it at the beginning of the bounce. So what the shock absorbers do is the shock absorbers stop the springs from bouncing. So in other words, what they do is, if we go back to high school physics, energy is neither created nor destroyed. It is merely only ever transferred. So the vehicle traveling along the road hits a pothole or a bump in the road. That movement causes kinetic energy. Kinetic energy goes into the spring. The spring then transfers the kinetic energy into the shock absorber, and the shock absorber transfers that kinetic energy, interestingly enough, into heat energy as it transfers across in what it does. So the shock absorbers, by doing that, keep the tires firmly down on the road and stop the tires from bouncing. Now, in that, you'll see just now that any bouncing of that nature that occurs translates directly to the wear pattern on the tires. And as I spoke about last time, which is now roughly a month ago, the wear indicators of the tires, where there are flat patches on the tires, is usually an indication of suspension failure and or shock absorber failure within the system. And just bear in mind, shock absorbers are one component in the suspension system, and there are many others. However, we're just going to concentrate today on the one, which is the shock. So what are the effects of shock absorbers? At 80 kilometers an hour, when you need to brake in an emergency, if your shock absorbers are not functional and effective, you're going to take 2 to 3 meters longer to stop because your tires are not being kept down on the road. Your traction on the road surface is not what it should be. And that's, as the comment says, irrespective of even with ABS or ESP. ABS being anti-brake lock system and ESP electronic stability programming. And this can obviously be the difference between stopping safely and hitting a hazard. You'll have also less control of your vehicle when cornering, towing, or driving in wet or wintry conditions. Let's not worry about the wet or wintry conditions. In theory, when you are cornering with shock absorbers that are not working as well as they should and are no longer in a 100% condition, the body roll of the vehicle continues further than it should on the compression stroke of the shock absorber and on the relief stroke of the shock absorber. It'll also overextend the travel that it goes through. And that's when the car feels, or the vehicle feels, like it's wallowing in and out of corners as it progresses. Other components may also start to wear as they compensate for the worn shock absorbers. Now, what those are is things like your ball joints, your tie rod ends, your springs as well, upper and lower control arms, all overextend beyond where they should and where they are meant to operate within their measured operating distance and travel distances. So let's just look at shock absorbers for a moment. Shock absorbers reduce bounce, roll or sway, brake dive, and acceleration squat. Acceleration squat, obviously, if you accelerate hard, you've seen cars on racetracks and so on, where when they pull away from the line at the green flag, the car almost looks like it goes down like a greyhound on takeoff after a rabbit. And that's because of the excessive acceleration force of that vehicle. And you don't want that in your normal road car or road vehicle. So you have an upper mount in the shock absorber. Up at the top, you have a piston rod, you have seals, bushing, pressure tube, piston, reserve tube, base valve, and lower mounting. And obviously all of these are significantly different depending on the vehicle. The important thing that needs to be borne in mind is this angle or this line across here in the center, which is the diameter of the shock absorber. In many respects, the diameter of the shock absorber is what determines whether what the shock absorber's capability or capacity is to perform its role. A very thin shock absorber is nice and light, but it obviously doesn't have much in the way of capability of excessive load shock damping. Whereas the broader the diameter, the more capacity the shock absorber has, by virtue of the fact that the more capacity, the more ability there is for the heat that is generated during compression and extension to be contained and to be transferred. So in essence, they're very complicated items, and they deserve more respect than they generally get. Now, what I want to talk about just quickly while we've got this diagram on the screen is in fact this section here, which is where the piston is in the center. Now, what I always try and explain to everybody is that although the manufacturers recommend shock absorbers should be replaced every 80,000 kilometers, the Americans call it 50,000 miles, but we say 80,000 kilometers, is because in a single kilometer, this shock absorber goes up and down in a compression and extension stroke in the region of 2,000 times in a kilometer. And it can be more than that, but roughly on average 2,000 strokes up and down. But those are not full length strokes. Those are short little strokes just concentrated in this area. So the natural occurrence that takes place is that in this particular area, the wear is accelerated in the internals of the shock absorber, both on the seals and the sleeve tube of the shock absorber. So one needs to bear in mind that over the life of the shock absorber, 80,000 kilometers, there's an enormous amount of resistance to wear, but also as wear takes place in this region is where the shock absorber then starts losing its capability to do its task, and that extension starts becoming further and further as the worn tube allows more material, more fluid or gas to go past it more easily. So when it reaches an unworn section, then it'll compress as it's supposed to, or when it reaches an unworn section at the top, it'll start extending the way it's supposed to. But in the middle, it starts bouncing and allows the spring to bounce, which is where your tires start slapping the road and getting tire wear marks on them. So I thought I'd just spend a few minutes on that particular issue. Now these are shock absorbers. The next picture we've got is to do with the struts. The strut has a secondary role. A shock absorber is a straight shock absorber as it is. It's a single piece. The McPherson strut, as we know it, incorporates the spring on the top of it as well. And it provides the structural support to the vehicle suspension where it's operating. Now, typically, this is used in an independent suspension structure and setup where you need to limit unsprung mass and you need to provide as much steering angle support as possible in the vehicle at any point in time. So although they're basically the same internally, the difference being that the McPherson strut carries the spring on top of it as well. Now, going back to the valving that I was talking about earlier, these are 3 diagrams, and let's not get too involved in the diagrams, but fundamentally what I wanted to put together or show you here was in fact this piece here, which is the internal valve of the shock absorber. Both there, that's the bottom valve. This is a central tube valve. And these are different configurations of valves that cause the shock absorber's compression and extension strokes to operate at different levels. Now, you'll see here, they refer to that at slow piston rod speeds, the fluid passes through the predetermined orifice in the area in the valve seat. So that's literally within this middle space here. It allows the fluid to travel in and out through the side. And that's obviously a tiny little orifice, and it allows it. But the moment it gets too high a speed, so we now move into medium speed, these are bimetal plates that are valving here, and they open and close through force and control the rate at which the blow-off of the gas or the hydraulic fluid goes past up and down on the compression or extension stroke. And then at high speeds, you have the spring valve in the center that controls the rate at which the material passes through. So it's a complex piece of equipment, and it's very important that one bears in mind that these are also wear items. These blow-off valve plates are going up and down as the shock oscillates at 2,000 times per kilometer. These are opening and closing all the time. So this effectively, which is referred to as the orifice, is a protection for these plates to an extent, but whereafter they have to take over and perform the role that they are intended for. So there's a lot of wear aspect that does take place in center here. Now, before we move on from this picture, I'm just going to clear these drawings quickly, my scribblings, and I'm going to go back and I'm going to refer to this piece here, which is the threaded section of the shock absorber, internally in the shock absorber. When one uses a air impact wrench to fit a shock absorber at the top, especially a McPherson strut, the impact that occurs and pushes down through the piston shaft completely impacts also on this threaded area of the shock absorber. And it causes this is basically a screwed on what they call a securing nut. This securing nut comes loose. And within a month or two or couple of kilometers even, this can drop right off. And then you have no shock absorber anymore. You just have a piston going up and down, free flow. And people wonder why it happens. And it's purely because the impact that is pushed down through the shaft from the impact wrench at the top whilst trying to tighten it. It's not the turning motion. It's actually the impact forces that come down and travel right down that loosen this thread inside. So if you're ever having shock absorbers fitted, or you are fitting shock absorbers yourself, we appeal to you to please don't use an impact wrench, because it's not the way to do it. There are correct methods and correct tools to use when doing that. So I think it just was a nice opportunity for me to share that with you to get the illustration of that correct. I spoke about typical unsprung weight stroke mass and the typical sprung weight. The typical unsprung weight is what affects road holding dramatically in any vehicle. So the unsprung mass is made up of wheels, tires, brakes, side shafts, CV joints, wheel hubs, and wheel bearings. And the unsprung mass is the mass that the shock absorber has to overcome in terms of kinetic energy in holding the tire down on the road. So if we look at the sprung weight, the chassis, body, load, passengers, engine, transmission, etc., everything above the springs, that is pushing down. But your unsprung weight here, when that, sorry, I'll just jump to screen. When you look at this unsprung weight here, which is below the spring and below the shock absorber, that's what causes the kinetic energy transfer into the suspension system that has to be overcome by the spring and by the shock absorber. The spring holds it up, the shock absorber stops the spring bouncing. So that's effectively what it's about. And you want your sprung weight at the top to remain as stable as possible whilst this is vibrating and oscillating. So if you had to feel 2,000 bumps every kilometer on a tar road traveling into your vehicle, you wouldn't enjoy driving your vehicle either. So I think that's quite an important part of it. I think if you think about a bicycle down a road, nowadays people put many of the fancy bicycles have got shock absorbers in them as well for the same reason. But a normal road bike with solid chassis or frame can become quite an interesting experience even on a tar road. So the road holding is affected by the unsprung weight. So the bigger the wheels, the higher the unsprung weight, the more the effect on the road holding. Again, if you go too light on your unsprung weight, then your springs and shock absorbers are going to be overcompensating for that mass, and it won't be a happy place in terms of how your suspension system operates. When you want to inspect shocks and struts, it's important that there are a couple of tests. Firstly, obviously, the car park test, where one would drive the vehicle, and it's usually preferable to get someone else to drive it, get someone who's a qualified technician to drive the vehicle to feel it, because as I normally refer to it, shock absorbers create what is called the frog effect, where, and I hope there's nobody listening who's going to be offended by what I say, but effectively you condition the situation, or you as a human become conditioned to the worn shock absorbers. Like a frog in hot water, if you put a frog into a bowl of hot water, it'll jump out. If you put a frog into a bowl of cold water and slowly heat it up, the frog will stay in the water. Unfortunately, it's an illustration that is what applies in this instance. We drive the vehicle from new, and gradually over the next 80,000 kilometers, we compensate for it. We become comfortable with it, and we don't even notice that the shock absorbers are allowing the car to wallow. We compensate, we drive differently, we brake earlier, etc. Then we change the shock absorbers and we think, my goodness me, this car's now got a hard ride. Why? What's gone wrong? These guys have fitted the wrong shock absorbers. And it's all because you've become so used to it. So in the car park test, it's preferable to have someone who's qualified to do such a test, do it for you. Someone who's not familiar with your vehicle, who can tell you straight away that the handling of the vehicle is not great. Car park test would typically be an acceleration pull away, a braking section, and a moderate swerve from left to right to feel the body roll. You should also be able to see the impact of shock absorbers and suspension failure in your front and rear tire wear. I mentioned a month ago that the most predominant early warning of shock absorber deterioration is heel and toe feather wear on the outer edge of the tires. It's easy to feel. You run your hand over it. If the tires feel as though they are rough and have edges, then you would probably have the beginnings of heel and toe feather wear, which is an example of tire of shock absorber wear. Excuse me. Upper strut mount inspection, that's a case of looking at the strut mounting itself. And I'll share with you in a moment or two a couple of things to look at there. But essentially, it's about looking at the upper strut mount in the engine bay and seeing whether they are corroded, whether the rubbers are cracked or perished, etc., because it all impacts on how the shock absorber below it operate. And as a rule of thumb, we recommend when replacing McPherson struts, where mounts are used, we suggest that it's absolutely imperative to change the mount at the same time. The mountings are not expensive, and it just really makes it a lot easier going forward. I've seen many cases where shock absorbers have failed because an old mount has been used. New shocks have been fitted, an old mounting has been left in, and the shock absorber has failed because that mounting wasn't in suitable condition, and it's actually worn off the top section of the McPherson strut piston and created an unsafe condition. Obviously, the visual test, and I'll go into the visual test shortly, but there are certain tricks around the visual test which are extremely simple. Is it leaking oil? Are there scratch marks on the pistons? And does the shock absorber generally look in poor condition? Finally, when getting around to replacement, it's every single manufacturer, and it's not a commercial recommendation. It's a engineering recommendation that one replaces all 4 units at the same time. It's not worth skimping trying to do one at a time or just the front or just the rear, because what you will do is you'll have compensation take place that you don't want in the opposite shock absorbers. So signs that your shock absorbers could be worn and need replacing. You should replace your shocks every 80,000 kilometers. You could have a nosedive where it's harsh on the brakes and the suspension, loss of rear brakes, traction, not loose, sorry, spelling mistake. Harshness, internal impact, abrupt reaction. In other words, the shock absorbers cause the suspension to have a jerky motion. Body roll, as I mentioned, using an expert to road test the vehicle for you. Tire wear, we've spoken about tire wear. Acceleration squat, I mentioned the racetrack conditions of high acceleration. Swerving from side to side, unresponsive. So what that is in opposite to the road test is if the vehicle feels like it's swerving and you have to continually correct as it goes over a bump or some uneven surface, the vehicle starts feeling as though it wants to veer across the road. Bottom out, if you go over a bump and the shock absorber doesn't have sufficient compression, and it allows the shock absorber itself to bottom out into its mounting and gives you that solid thud sound as it reaches the full compression stroke. Traction loss, obviously, we've spoken about that, where the shock absorbers are solely responsible for keeping the tires down on the road. The example is, I'm sure all of you at some stage have seen a vehicle traveling along the road with a wheel, either a rear wheel or a front wheel, or more bouncing up and down as it goes along the road. And that's a classic indication of a shock absorber that's now given up the ghost and is no longer performing the way it should at all. And you can imagine, having seen that, why the tire wear is what it is in the structure. So shock absorber failure, normally oil leakage. Normally oil leakage occurs as a result of a damaged oil seal or bushing. Any damage to the piston rod can affect the oil seal. Now, I'll chat about it in a moment or two. Just how we get damage on the piston. We can have corrosion that occurs. That's the left-hand side. We can have damage by tools. This is a great one where when fitting a shock absorber or a strut to a vehicle, we want to get the top nut tight. We don't know how to get it tight because it keeps turning. So we put a vice grip on the piston rod, and Bob's your auntie, that's the end of that piston. Because the moment that mark that is caused by the vice grips, the moment that mark goes past the seal in the top of the shock absorber, it will score that seal and will leave a permanent scoring in the seal, and that will cause an oil leak. And as the oil leaks out, so your shock absorber fails. And damage on one side of the piston, this is often because of an incorrect installation as well. It can also be when somebody has a tire rubbing against a piston rod. There are various things, but the bottom line is you can see these marks and these indications on the side of the shock absorbers. Physical action, bent or defected. Okay, we won't worry about putting frozen liquid into the strut because that's just for motor racing. But yes, you put frozen liquid into the cartridge and it'll collapse the cartridge through freezing. The thread of the eye-ring is broken or torn, obviously, and will affect how it works. Bent piston rod at the bottom. Naturally, I don't think that shock absorber is likely to work anymore. And then obviously on the right-hand side, in the top of the shock absorber broken off or sheared off, usually because of an impact wrench and or over-tightening, which is, as anybody knows, as dangerous or as silly as leaving it loose. Noise, again, noise comes from circlips on rods, damage on the piston rods, bent piston rods, loose mountings at the bottom. There's a classic at the bottom of this shock absorber here, where typically, and I use the example of Volkswagen, they had two different sizes. They had a 50 mil and a 55 mil. And people would put the 50 mil shock into the 55 mil mounting and try and tighten it as best they could. And they'd put shims around it. And inevitably, it would actually end up wearing the shock and damaging the bottom of the shock, causing noise. Noise from inside the shock can occur, and it usually is, or quite often is, that there's either been some other damage to the shock, the impact wrench being used on it, or somebody's let some of the fluid or the gas out of it by some chance. But let's just understand that these are extreme conditions that we're talking about here. Shock absorber fitting tips. Again, don't, and I stress it, don't hold the piston rod with any tools like mole grips or vice grips or whatever you want to call them, as those teeth on those vice grips bite into the piston and they will leave marks which will cause the oil seals to leak. Guaranteed, 100%. If you're working with a cartridge shock absorber, don't put anything into it. Leave it as it is and use it the way it's meant to be. And do not use an impact wrench to tighten the nut on a piston rod. This can make the torque higher than the recommended limit, but it also, as I mentioned to you earlier, it drives the impact, the vibration impact, down into the shock absorber, loosening the bottom of it. Use only the fitting parts that come with it. Do not try and mix parts between different shock absorbers, old parts, new nuts, new washers. Use everything the way it's supplied. And as it says there, shock absorbers should always be fitted in pairs, at least in pairs, left and right, but preferably front and rear as well. Just to talk about springs briefly, three main different types of spring systems. You have your leaf springs, which I'm pretty sure most people are familiar with, either from the rear of a bakkie or a trailer. The torsion bar spring, which is the bar that gets twisted and provides the lift in the twisting of the shaft. Very common in four-wheel drive bakkies and so on. And then obviously the coil spring. This particular individual picture here is what would be called a progressive spring. Progressive because the coils at the top are far closer and tighter coiled than the ones at the bottom. So the bottom will compress first, and then these will compress later as the need comes in. So it gives it an adjustable or a variable compression in the spring as it's needed on the compression stroke. Typical rear suspension configuration. This is a what is called live axle, solid axle, trailing link suspension with a coil spring and a shock absorber. So very simple system, coil spring holding it up, shock absorber positioned. Many times you'll see this one or other shock absorber facing the other way. So they work in opposite directions. You'll see this on the right-hand side picture here on the leaf spring. It's the one counters the other in terms of how they operate and how they dampen the compressions. Strut mountings keep the struts firmly in place and absorb some of the shocks from the road bumps. So what we always say is that the unsprung mass needs to be separated from the sprung mass. It has to be suspended. So if we just look at a CV joint is suspended in grease, which keeps it separated from the unsprung mass. Similarly, the shock absorber, if this was bolted straight into the bodywork with no form of rubber mounting, it would cause vibration and sound transfer into the bodywork. And that's briefly what the strut mounts look like. They're not expensive and they're worth replacing at the time. There are 9 bad strut mount symptoms. Noisy strut mount, they don't give such good vibrations, steering issues, tire alignment, tire wear, excessive movement, damaged components, poor condition, rubber condition, and corrosion. Corrosion is the biggest one along the coastline, obviously, because that's where strut mounts get hammered with the road debris coming up and causing them to corrode, especially from underneath. So in conclusion, ladies and gentlemen, shock absorbers have a lifespan. They're not for life. They have 80,000 kilometer lifespan. They are part of the suspension components, and and all suspension components wear. Suspension is safety critical. It's life and limb critical to you and all your staff driving the vehicle. And we urge you to budget into the vehicle maintenance plan for regular maintenance of shock absorbers and suspension, in fact. Balancing rotation and alignment of wheels and tires every 8,000 kilometers also gives an opportunity for shocks to be inspected. Budget for shock absorbers at least 80 every 80,000 kilometers. For the best value, replace shock mountings at every time as well. Remember, springs hold the vehicle up, giving ride height, not the shocks. Shocks keep the tires on the road. The more you load the vehicle, the harder the suspension works, and the more frequently it will need replacement. So if you are overloading your bucky and you are driving it over rough conditions, the shock absorbers are not likely to last 80,000 kilometers. They may, but it's unlikely. You are overstressing the system. So it's worth making sure that you get the suspension checked and the alignment rotation done every 80,000 Ks or every 8,000 Ks, sorry, so that you can get fresh and regular information about it. Thank you very much from the RMI and the Tire Equipment Parts Association, a proud association of the RMI.